On with Unit 5. We are in the middle of Learning Target 5B, which is all about different types of equations of lines. By the end of this lesson, you will be able to, given a point and a slope, write an equation for a line in point-slope form. Given a line in point-slope form, we will learn how to graph it. And lastly, given 2 points, we will be able to write an equation of a line in point-slope form. So this second video here in Learning Target 5B is going to focus on a different type of equation. These are still equations of lines, but this is called point-slope form. So the point-slope form of an equation of a non-vertical line with slope m that passes through the point x1, y1 is given as y minus y1 equals m times x minus x1. So in our last video, we learned about slope-intercept form. That was in our first part of Learning Target 5B. And slope-intercept form was that y equals mx plus b. Now this slope-intercept form is an equation of a line. Point-slope form is another equation of a line. So they're actually equivalent equations, they're just two different ways to write an equation of a line. It really depends on what information are you given to know which one is helpful to use. So the slope-intercept form is helpful when you have a slope, which remember is your m value, and when you have a y-intercept, which is 0, b. Now, point-slope form comes in handy because we don't always have a y-intercept, and we wouldn't have to always want to find a y-intercept first to be able to write the equation of a line. So point-slope form allows us to, if we're given the slope still, so I still need the slope, but I can use any other point. So given a slope in any point, point-slope form will then allow me to write the equation of a line. And when we're using point-slope form, our slope will go in front of these parentheses here. So notice there are parentheses now around this x minus x1, and then this coordinate pair, x1 will get subbed in as x minus that number, and y1 will get subbed in as y minus that number as well. In these first couple examples, what we're going to practice doing is just given information, write the equation in point-slope form. So the instructions say write the equation for the line in point-slope form given a point and the slope. Again, I want to draw your attention to this phrasing. They don't tell you what the equation is, they just give you the name for the equation. So what we have to remember is that point-slope form is our y minus y1 equals m times the quantity x minus x1. So it's important to have the vocab words down, but to also know what equations they're talking about. Let's look at example 1. So example 1 says that the point we're given is -3, 6, and our slope is -5. Well, that tells me that my x1 is -3, and my y1 is +6, and my slope, which is my m value, would be -5. I'm going to rewrite point-slope form in general, and I suggest that you do these, start writing it in general in a lot of these examples just to help you memorize it. So y minus y1 equals m times the quantity x minus x1 is our point-slope form. And now I'm going to substitute each of those pieces in. So x and y are not going to change. So I'm still going to have these parentheses. I'm going to have x minus some number and y minus another number. Now y1, remember, is our +6. So I'm going to get y minus 6 then equals my m value is -5 since that's our slope. So I get -5 times, make sure you have the parentheses, and x minus our x1 value is going to be -3. And I'll sub that in as x minus -3. I can simplify this a little bit more just with the two negatives, so my final answer will be y minus 6 equals -5 times x plus 3 then. And that right there will be our final equation in point-slope form for this line. Let's look at example 2. So example 2 says our point is 2, 4, and our slope is equal to 7. Let's rewrite the general equation. So point-slope form is y minus y1 equals m times x minus x1. Why don't you guys pause the video and substitute everything in, and then we'll check it together. So in this example, I need my y1 and my x1. So y1 is going to be our 4, since it's the y portion of the coordinate pair. Our slope is 7, so my m value is going to be 7 times x minus our x1 is going to be 2. There's nothing else I can simplify from here. I don't want to solve for anything. I want to leave it in this form. So there is our final answer. Okay, why don't you guys do example 3 and then we'll check it together. So in example 3, we have 1 comma negative 7 as our point, and our slope is equal to positive 3. Again, I'm going to keep rewriting our general equation for point slope form, point slope form. So we have y minus y1 equals m times x minus x1. Subbing stuff in, I get y minus negative 7 equals, our slope is 3 times x minus 1. That is point slope form, but I want to just make sure that I don't have any minus negative numbers, so I can simplify that as y plus 7 equals 3 times x minus 1. And that will be our point slope form for that example. Why don't you guys pause the video and do example 4 on your own first. Let's check example 4. So we have the point negative 10 comma negative 1 and a slope of 3 over 2. I'm going to keep writing this general equation just so that I have it down. So point slope form is y minus y1 equals m times x minus x1. So I get y minus negative 1 equals, our slope is 3 halves times x minus a negative 10 from our x1 value. Last thing left to do is simplify this a little bit. So y minus a negative 1 would give us y plus 1 equals 3 halves, and then I'll simplify to the x plus 10. And there is our, I don't want to draw over the next problem, but there is our equation in point slope form for example number 4. Let's check example number 5. So we have 1 comma negative 9 as our point, and our slope is negative 4. So our point slope form in general, y minus y1 equals m times x minus x1. So subbing in, I get y minus negative 9 equals, my slope is negative 4 this time, times x minus 1. Last thing to do is I can rewrite this as y plus 9 equals negative 4 times x minus 1. And there is our equation in point slope form. Okay, we have one last example here, and I'm sorry, I kind of wrote over that. I believe, yes, that was the number 1 there, so we can see it. Why don't you guys pause the video and do example 6, and then we'll check it together. Hey, example 6 says the point is negative 8 comma 6, and our slope is negative 1 over 7. So I need point slope form written out in general. Y minus y1 equals m times x minus x1. Subbing in, I get y minus 6 equals negative 1 over 7 as my slope. Make sure you have these parentheses. I get x minus a negative 8. Last thing to do is rewrite x minus negative 8 as x plus 8. And there is our point slope form for that equation of a line. All right, now that we've had practice taking the information and writing the equation of the line, we're going to kind of do the opposite, and at the same time we're going to practice our graphing skills. So in these instructions they say graph the following. So we have an equation here in point slope form. It says y minus 1 equals 2/3 times x minus 2. To be able to graph this, I'm going to need to know, well, what is that slope and what is that point? So in our last video, we found our slope and our y-intercept since we were in slope-intercept form. But since we're in point slope form, we're going to find our slope and our coordinate pair, so the point that we have. We're going to start, before we even graph it, we have to find this information. So I'm going to do the opposite of what we did in examples 1 through 6. So in examples 1 through 6, we had the information and we wrote the equation. Now I want to extract that information out of the equation. So let's write point slope form in general off on the side. So I'm going to abbreviate point with just PT. So it's y minus y1 equals m times x minus x1. Remember, m is your slope, and x1 comma y1 is that point that we're looking for. So in this first example, 2/3 is in the spot of the m value, so 2/3 will be our slope. And then our point is coming from the numbers that we're subtracting, so the 2 and the 1. But we want to make sure we're writing it as x comma y, so I have 2 first and then the positive 1. And the reason that both numbers are going to stay as positives and I don't take the negative signs with them is because in the general equation I have y minus the number and x minus that number. And we'll notice that x1 and y1 were just those exact values that were pulled out. So the negative sign actually stays behind. If we had a positive sign, we'll look at what happens in another example with that guy. Now that we have our slope and our point, we can go ahead and graph this guy. So I'm going to start by plotting that point. So I'm at 2, 1. So although it's not a y-intercept, it's still a point on the graph. And now I can use my slope and I can think about my rise over my run to get my next value. So since my slope is 2/3, that means I'm rising by 2, so I'm going up 2. So I'll go up 1, 2 from our point, and then I'm going to the right 3. Right. So from my point, I go up 1, 2, and then I go to the right 1, 2, 3. I'll put my next dot there, and I have my second coordinate pair. Remember, all we need are 2 points to form a straight line. So using your straight edge, using your ruler, make sure you draw the line across the entire graph. And there is our straight line for us. All right, let's look at example 8. So in example 8, we're going to have a little bit extra work to do. So it says y plus 3 equals -5/2 times x minus 1. Remember that general form here was y minus the number and x minus the number. Well, the x value is good. That's x minus 1. I want to rewrite y plus 3 so that it's y minus a number. What number would go in place there if I'm trying to rewrite y plus 3 as y minus a number? The number that we would have would be -3. And the reason being is that two negatives make a positive when I multiply them, so y plus 3 is the same thing as y minus a -3. And we had seen this in reverse up above. So if we look at example 3 here, remember our y1 value was -7, so when we subbed it in, we had y minus a -7, which we rewrote as y plus 7. So now we want to do the opposite and kind of pull that apart and make it the unsimplified version from there. On the other side, I still have -5/2, and then x minus 1 is already good since it's x minus a number. The reason I had us do that is so that I can see what my slope and my y-intercept, what my slope and my point is a little bit easier. So what do you guys think? What is our slope and what is our point for example 8? So our slope is going to be -5/2, and our point is going to be 1, -3. Remember, I want the negative sign in there, so I just take the numbers after the negative sign. So +1, and in this case, -3 because of the two negatives. Now we can use this information to graph. So I'm going to go ahead and plot 1, -3 first. So I go to the right one, go down 1, 2, 3, and I have my first coordinate pair on the graph. The next thing I have to use is my slope. So my slope is -5/2. That means, should my line be going up? Should my line be going down? What do you guys think? So our line should be falling because my slope is negative, so the line should be going down. So when I talk about this, I'm actually falling by 5. So I'm going to go down 5, and then I'm going to go to the right 2. So I can go down 1, 2, 3, and then 4, 5. All of a sudden, I'm off the graph. So I could guesstimate it, but that's not going to give me a precise graph. So another way to think about this is instead of putting the negative sign with the 5, what if I put the negative sign with the 2, and I look at it as 5/-2? what that would tell me is that I actually go up 5 and then to the left 2, which we can do. So I can go up 1, 2, 3, 4, 5, and then, so let me draw those 1, 2, 3, 4, 5, and then to the left 1, 2. And our second coordinate pair will go there. And this still works because my line is still going to fall over time. Now, if I would have had enough space on my graph to go down 5 and to the right 2, I could have. I just didn't know exactly where that was, and I want to make sure that my graph is precise. So to fix that, we just move the negative sign to go with the 2. So 5 now represents going up since it's positive, and 2 represents us going to the left since it's negative. I'm going to use my ruler or my straight edge and go ahead and insert a line here for us as it goes through. I'm going to have to edit that slope a little bit. There we go. And line it up. Okay, making sure again our graph is going on the entire coordinate plane. Okay, let's look at example 9. So in example 9, it says y plus 1 equals 3 times x plus 4. Why don't you guys pause the video right now and determine what your slope is and what your point is going to be equal to. Okay, let's check this. So in this equation, I want to kind of rewrite it. So when I have this y plus 1, remember our general form says y minus 1 equals m times x minus x1. So I want to rewrite the y plus 1 as y minus a negative 1 equals 3 times, I want to rewrite it over here as well as x minus a negative 4. And that way I can see that my slope we knew was 3, but our point is going to be negative 4 comma negative 1. So what's happening here is when we have these, we're actually flipping the sign. So when the numbers say y plus that number, I'm going to make it negative in my point. And if it says x or y minus the number, then I'll flip it and make it the positive, just because the general equation itself has the minus sign in it. Now that I have that information, I'm going to go ahead and plot the points. I'm going to go to the left 1, 2, 3, 4, and down 1. So there is my first coordinate pair. And now I can use the slope of 3. And remember, 3 is the same thing as 3 over 1, which means I'm going to go up 3 and then to the right 1 since they're both positive. So I'll go up 1, 1, 2, 3, and then to the right 1. I will plot my next point. And then I can graph my line from here. So using our ruler, I can insert this line. Whoops, let's make sure it extends throughout the entire graph then. One thing I want to point out is we technically didn't have to do it this way. So if I look at example 9, let's rewrite this. We have y plus 1 equals 3 times x plus 4. In our last video, we looked at, well, how can I graph from slope-intercept form? And in this video, we're looking at how can I graph from point-slope form. They're actually the same concepts, we're just using different points. But I can take any point-slope form equation and change it into slope-intercept. So remember, our slope-intercept equation is y equals mx plus b. So to go from point-slope form, which is this y minus y1 equals m times x minus x1, I can actually go to slope-intercept form by distributing our slope and isolating our y value. So I can go from point slope to slope-intercept form by isolating and solving for our y variable. So let's go ahead and do that on this example. So to do that, I'd first distribute the 3. So I'll get y plus 1 equals 3x plus 12. And then to isolate the y, I'm going to subtract 1, and I'll get y equals 3x plus 11. So in example 9, we started with point-slope form, and then by isolating our y value, we were able to change that into our slope-intercept form. And that's okay. That could also help us graph. I wouldn't suggest it on examples like 7 or 8 because our slopes are fractions. And so by distributing that, we would then have to add the 1 over, and I would need a common denominator, and that's a lot more work than just finding the point and finding the slope and graphing from there. But in example 9, since my slope is an integer value, it's a little bit easier to convert from point slope to slope-intercept form. So if this is a way you're more comfortable with, you could first isolate the y value. Now that I'm in slope-intercept form, let's do a little bit of review here. What would our slope be, and what would our y-intercept be? So our slope would be 3, which hopefully is making sense. If I came from this point-slope form equation where I had a slope that was 3, then my slope shouldn't be changing, because no matter which equation I am in, remember that slope value is still that m value. So my slope is still 3. My y-intercept is going to be 0, positive 11. Well, if I look to this graph now, 0, positive 11 is not even on the graph, which is why our purple line here just kind of keeps going up and it never intersects the y-axis yet, since positive 11 is going to be way up here. So in this case, it was actually probably easier to graph it in point-slope form, since that was part of the graph paper that we already had, and that's where those values were. But it is possible to go from point-slope form to slope-intercept form by isolating the y value. Okay, let's look at our last sets of examples. So in example 10 through 13, what we're going to be doing is it says write the equation for the line in point-slope form given 2 points. So there's a little review right here. What is the general equation for point-slope form? So the general equation for point-slope form is y minus y1 equals m times x minus x1. Remember, we want to make sure we know the difference between slope-intercept form and point-slope form. So in example 10, I'm given 2 points, -2, -3, and 1, 4. They want us to write an equation in point-slope form, which means I need a point and I need a slope. Well, I have a point. I actually have 2 points, so I'm good there, but I need to be able to find my slope. How can we find our slope given 2 points? Well, if we think back to our first video in this unit, our slope was defined to be y2 minus y1 over x2 minus x1. So for the slope, I actually need to find it, or compute it would probably be a better phrase, but I need to first compute the slope by using our slope equation. So why don't you guys pause the video and find the slope between these 2 points that are given. Okay, let's check our slope value. So y2 I'm going to use to be 4 minus our y1 will be -3 over, our x2 will be 1 minus our x1 will be -2. Simplifying this down, I have 4 plus 3 over 1 plus 2, so I end up with 7 over 3. So I was able to find my slope. So remember, our m is our slope. To write an equation in point-slope form, I need a point and I need a slope. Well, I have 2 points and I have a slope. Do you guys think it matters which point we use? It actually doesn't matter. They would both be equivalent. So what we get to do is pick your favorite point. So pick either point. It doesn't matter which one you're using, but make sure you're using either the -2, -3 or the 1, 4. I'm going to write out both of them just so that we can see that for practice. So I'm going to first do our answer with -2, -3. So in both of them, remember our slope is 7/3. So point slope form, y minus y1. So I'll get y minus a -3 equals our slope, which is 7/3 times x minus a -2. Simplifying that down, I'll get y plus 3 equals 7/3 times x plus 2. And that could be one of our answers for example 10 that uses the point -2, -3. Now we could also get an answer that would work if I use the point 1, 7. Or 1, 4, I'm sorry. So if I use the point 1, 4, point slope form tells me that's y minus 4 equals, our slope is still the same, 7/3 times x minus 1. And that would be also an answer. And either of these could be correct answers. So if it's on a free response problem, it doesn't matter which point you pick. Either one will work. You do not need to write both answers. You can pick your favorite point and write that equation. On a multiple choice problem, if you ever have it in that format, you have to just make sure you're picking the correct answer. So if you pick the first point and you write it out and that's not an option, it doesn't mean you did anything wrong. I would just use the second point and write that equation out and see if that's an option instead. Because on a multiple choice, they wouldn't put both options down, they would just have one of these. Okay, let's look at example 11. So same instructions, write the equation for a line in point-slope form given 2 points. So what is the first thing I have to do if I'm given 2 points to be able to write a line in point-slope form? I have to find the slope first. So let's calculate our slope. Remember, it's y2 minus y1 over x2 minus x1. So I'll get 1 minus 2 for our y2 minus y1 over 2 minus negative 4 for our x2 minus our x1. When we simplify this down, I'll get negative 1 over 2 plus 4, so I'll end up with negative 1 over 6 as my slope. To go to point slope form now, I have a point, I actually have 2 points, and I have my slope, so pick my favorite point and write my equation. Let's start with negative 4 comma 2. Why don't you guys pause the video and use negative 4 comma 2 and the slope of negative 1, 6 and write the equation in point slope form. When we write this out, remember we get y minus y1, so y minus 2 equals my slope times x minus x1, but I can simplify that down to be x plus 4 since I would technically get x minus the negative 4. And that would be one option for our final answer, using the negative 4 comma 2. But I could also use the 2 comma 1. So why don't you guys pause the video and write down the equation that would use 2 comma 1 and the negative 1, 6. I'd get y minus 1 equals negative 1, 6 times x minus 2. And remember, either of those answers would be correct. Okay, let's look at example 12. Why don't you guys pause the video and do example 12 on your own first. Let's check example 12. So we have 5 comma negative 1 and negative 9 comma 2, and my goal is a point slope form equation. So I have my points, but I need my slope. So let's calculate the slope. I would get 2 minus negative 1 for y2 minus y1 over negative 9 minus 5 for x2 minus x1. That would end up giving me 2 plus 1 over a negative 14. So I'd end up with 3 over a negative 14, which we could rewrite as negative, 3 over 14, and just kind of move the negative sign in front. I can't simplify the fraction anymore, so I have my slope. Let's use 5 comma negative 1 as our point. Remember, it does not matter which point you use. So I'll get y minus negative 1 equals negative 3 over 14 times x minus 5 using point slope form. If I just simplify that y minus negative 1, my final answer would give me y plus 1 equals negative 3 over 14 times x minus 5. And that could be one answer to question 12. Why don't you guys find what the other answer could be using the other point? So if we use negative 9 comma 2, then I would get y minus y1, so y minus 2, equals, our slope is still the same, so negative 3 over 14, times x minus a negative 9, which would turn into x plus 9. And either of those two answers would work. It would just depend on which point you wanted to use. Okay, last example. Why don't you guys pause the video and do example 13 on your own first. Let's check example 13. I need to find my slope first. I have 2 points and I want an equation of a line, so I have to have that slope. So let's start by computing it. I'll get 7 minus 3 for the y2 minus the y1 over negative 2 minus negative 8 for the x2 minus the x1. Simplifying that down, we'd get 4 over negative 2 plus 8, which would give me 4 over positive 6, which would reduce down to be 2/3. Now that I have my slope, I have a point, I have 2 points, so pick your favorite one and write your equation in point-slope form, and then we'll check them. Okay, let's check the first option, which would be if you use negative 8 comma 3, and we would end up with y minus 3 equals 2/3 times x minus a negative 8, so that would be x plus 8. There's our first option. If you decided to use the second point, let's check that one. So if I use negative 2 comma 7, I'd get y minus 7 equals, still 2/3 is our slope, and then x minus a negative 2, which would be x plus 2, and that would be our second equation. So in the second video here, we learned about what point-slope form is, and we did lots of examples with it, finding the information, starting with the information and writing the equation, how can we graph from point-slope form, and then in this last couple problems, we learned if I'm given 2 points, I can first find the slope between them, and then using that slope and picking my favorite point, I could write the equation in point-slope form.